Thanks for joining the session. I know we have a couple of the sessions going on and just finishing up, so we'll have some people trickling in. But let's get started. And I want to, before I welcome Betty, welcome Betty. Sorry, I guess I have to welcome you at this point. Why wait? I just wanted to mention a quick thank you again for all the folks that have chosen to speak, taking the time, Betty included. Thanks for you guys for joining. Thanks for the sponsors. The one thing I will mention is if you go into the booth section, as I mentioned, there's some sponsors that are giving away a couple $100 gift cards for Amazon and other easy things to sign up for. So it's just one click. So make sure you do that. Don't forget before the end of the session. It's just one click away. And yeah, thanks everyone. I hope you've enjoyed the session so far. In terms of the video content, those talks, I think the majority of them we have permissions to share. In some cases, PR doesn't want us to, so then in that case we can't. But for the most part, the videos will be edited and sent over after the session, including the workshops. But I digress. I don't want to take up more time. So let's introduce Betty. Betty is a data scientist at Amazon Web Services, where she shares her machine learning expertise internally as well as externally. So Betty has experience building and productionalizing computer vision algorithms, recommendation systems, demand forecasting systems across clients in different industries. So prior to Amazon, she worked at a startup that was helping develop and productionize machine learning algorithms in the retail space. So I'm very excited for this, Betty. Thank you so much for joining. I'll be here, so please, if anybody has any questions, put them in the chat. I'm sure I'll have a couple at the end as well. And I look forward to it. So Betty, I'll hand it over to you.
Thanks, David. Yeah, thank you for inviting me on to speak, and thank you for everybody who joined this call. So the topic for today is really just about how do we iterate and productionize machine learning model with speed. So how do we do it fast? So the agenda for today is I'll give a little brief introduction of myself. I know David already did, so I guess just adding more meat to that. I'll talk about why I think this is a really important topic. I'll then later on talk about some of the issues I see within the space, as in why it takes a long time to actually productionalize a model, give some solutions, as well as just providing a very end summary slide that kind of just encapsulates all the points I'll be going through in this presentation. So yeah, feel free to ask me any questions, and also just contact me after if you have additional questions. So just additional, I guess, brief introduction. I have around 7 years of experience working in the data space across multiple domains and industry. And the thing that absorbed the most is really that I've been fortunate enough to work both in the engineering space as well as the machine learning space. So I see a lot of sometimes gaps and sometimes also a lot of collaboration between how do you really productionalize a model from prototyping a model all the way to really handing that model over to the engineering team. And personally, I've also worked on projects where I did build the prototype of model and then eventually productionalize it. So I'm very familiar with the entire sort of life cycle. I'm Canadian, so I'm from Canada, and I moved to the Bay Area around 2 years ago. So I'm just currently enjoying this nice weather, which is very different from the Canadian cold temperature. And then now just jumping a little bit as in why I think this is a really important topic. So this is some stats that we have around the industry. So really only 53% of machine learning projects make it from prototype to production. And only 10% for the companies that are self-developing a data-driven culture. So what that means is that you still have half of the models that people sort of build in prototype, that people spend a lot of time build, that just did not make it into production. And especially for the companies that are still new to the space, majority of the models actually don't make it into production. And one of the big reasons for that is it normally takes around 6 to 12 months for the initial launch of a machine learning project. So what that means is typically it takes a really long time, right? It takes around half a year to a year for a company, for a team to actually build a machine learning prototype to be ready to be put into the production environment. But the issue then is that once it gets to that 6 month 1-year mark, we're going to see that there might be a misalignment between business objectives and the model that's already been built, because businesses typically move so fast. So it's possible what you were assigned to do a year ago, which, for example, you were assigned to build a train model. A year later, that business use case might not exist anymore, right? But you still have this model sitting there. That's one of the reasons why it's not getting pushed into production. But if you're really able to build and iterate and push things fast into production, you're going to have less of these issues, because as you iterate, it's no longer living in a vacuum. It's actually living in a space where people see and provide feedback and actually change direction and the course of a project and make it more successful. Another thing is that I think if you've heard, the more trials or the more things that you really do, the more chance that it's going to be successful. So let's say if you build a model in a year and the model is not successful, then you're sort of done. But if you're able to iterate and build 3 models in a year, then there's a higher chance of one of the models actually being successful. So it's a very important topic in the industry, and I think it's very worth sort of discussing about. And now I will just talk a little bit more about some of the issues that I see within the industry, as in why it's so hard to actually iterate and deploy models with a lot of speed. So, and then I'll also dive a little bit more detail. But there's 3 main things that I see. One is really you have a data and result drift. So that means is that you have inconsistent data or results. You're not able to push that model all the way to production. The second problem really lies around a skill set mismatch or some of the organizational challenges. So think about communication issues and clients not knowing exactly what they're looking for. And the third one is purely technical. The third one is really talking about the fact that for deep learning models or for some more complex models, it does take a little bit long time to train. And also the feature generation process also takes a little bit longer, but that one's sort of more purely technical. So dive a little bit more deeper for the data result drift. So what I mean is really sometimes data do drift over time. This could be a result of you training your model only on a small data set that later on changed. This could be a result of the way that you're extracting data actually contains some sort of bug over time, so that it's not pulling in all the data it requires. The second point is really sometimes we build models, but we lose track of the results. And sometimes you have a model that really gives you very good results, and you're trying to sort of push that into production, only to realize the results are mismatched, and you can't really find the code that give you the best result. And the third one is really around, some of the testing and validation issues. Again, going back to you build a model and you have some of the features that you use, but when you go into production, for some reasons, the features that you generated just look completely different from when you're testing. And then again, that's going to take you a lot of time to debug and figure out what went wrong. Some of the skill set mismatch or organizational challenges that we typically see include sometimes companies use a very waterfall approach, which means that you don't really start the second task before the first one starts. So you do feature generation, and then after that, you might be training a model, but it's in sequence. And sometimes we see that once the model is finished training, it might not give you the best results, but it's again going to take you a long time for you to start from data collection, feature engineering to training. Second point is that sometimes you see that you have some team members that don't really have the right skill sets for task assigned. So what this typically happens is that machine learning is still a relatively new space, and you have a lot of engineers or people from other disciplines who are trying to get into machine learning or trying to work on specific tasks on machine learning, and they don't really have the right skill sets to actually support a project. And the last two are really around, there's sometimes miscommunication between teams. So if you have a group of data scientists really build out models, and you have a group of engineers that are pushing models into production, there could be a lot of frustration points as the model or the team that's putting model into productions might not necessarily know exactly how to change some of the code, or they don't know how to prioritize certain workflows. And the last one's going back to sort of misalignment between what the business actually needs and the ML objectives. So this comes to sometimes maybe the business stakeholders could come in and ask you to build a machine learning model, but the business stakeholder might not know exactly what they need. And sometimes when you do provide an outcome, it might not be something that they're looking for exactly, 6 months down the road, which is also a very, very long time. And then third sort of large categories that problems that I typically see that hinders people from really iterating and deploying machine model with speed is just the purely technical part of it. Sometimes it takes a really long time to train a model, or sometimes it takes a really long time to generate some features. And there are many reasons for that. So sometimes we use very complex models in deployment. So when we're just iterating and building models, but they're actually really hard to implement in production because sometimes the results are not very reproducible, or the infrastructure is too complex for the production environment to support. Other issues that data size can really increase over time. So you could start with a very small data size, but over time it's really going to grow to a monstrous size of number. And you have to think about how you can deal with this issue. The third one is that models can also on its own become over complex over time. You think about implementing a model for different edge cases, or about just using an ensemble of different models, and that could also take a long time to train. And the last one is really just more like engineering debt. Sometimes you're running legacy code made by your other coworkers that might not be very fast, but you still have to use that code, and that also gives you a challenge to actually iterate and sort of productionize model fast. So these are sort of three categories of challenges that I sort of see in the industry. And I'll go a little bit more into some of the solutions that I think have worked well in the machine learning industry and really helping putting models into production. So again, I'll dive these a little bit more into detail. But the general solution is that when you're developing models, it's really about tracking metrics and versioning, and also just thinking about the fact that your goal is to put that model into production. You're not just iterating and really just trying out various methods. And that's a fine balance. The second one, when you're putting things into production, make sure that you're adopting a very DevOps approach. And again, I'll go a little more into detail. Third one is just simplify approaches or methods and streamline some of the processes. And the last is from a technical perspective, there are various ways to actually reduce the compute time that's required to run models and to run feature generation process. So this is really to help address some of the data drift, as well as some of the model versioning issues. So when you're doing development, what we typically ask machine learning engineers or data scientists is really to consistently track different metrics and versioning, at least set up different metrics that they actually want to track. So if you're talking about classification problem, then you might want to track precision and recall. And then on top of that, you might also want to track the time and cost for that particular model run, right? So for example, you could build something that's super complicated that do give you a little bit boost in terms of your precision and recall, but the time and cost are just 10 times what a basic model does. Then it's something that you should be looking at, and at least have a sense knowing, okay, if we do want to get additional 10% increase, this is the compromise that we have to make. And this is important to track while you're developing, because again, the goal is to put this model into production, which maximizes your impact. So tracking while you're developing gives you a sense of, what's feasible and what's reasonable, and keep you more grounded in that sense. The second part is really the machine learning team should start using containerization to run softwares and make it simpler for engineers to actually productionize their work. So some of the toolkits that you could use include Docker or other version controls. So that way your code is pretty much self-contained. It sits in a container. And then when the engineers run it, they really just have to run that container. And on the code level, it's consistent. And if there are issues, that it must be issues coming from other places, rather than having model producing different results. So that's what machine learning engineers or data scientists should do when they're doing the development phase. And then once it gets to the production phase, is really to adopt a DevOps approach. So what that means is that think about your typical DevOps pipeline, apply the same methodology to a machine learning production model. So set up data SLAs means, work with your engineering team and set up the requirements for different model requests or for even feature engineering. How long should that take? How long does it take currently to get a sense of what should be prioritized? Implement CI/CD pipeline that has good integration tests as well as unit tests to make sure that every time you push in a new model code change, it's not going to break anything or it's going to generate new metrics that you're really looking for. And the third part, it's, I would say, the most important part that sometimes is overlooked is really to invest in observability and monitoring. So again, going back, while you're developing a model, in the development phase, you should already know what kind of metrics you want to track from a data perspective. So whether it's the number of records or the variance of the data or the distribution of the data, to automate to the model metrics such as time, cost, your precision recall, or your MAPE. And then once you have that set up, really implement that while you're in the production environment to really make sure that those data, they don't really drift, or even if they drift, you know how to debug, right? Because sometimes what you get is that the model results look drastically different, but you really don't know whether if it's a model issue or whether it's a data issue. But having tracking at different level enables you to really look at where the issue might be coming from, and that saves a lot of debugging time. Again, there are a lot of tools that support that. Jenkins, there's UES, and some of the MLOps tools. And the third point is really just to simplify approaches and streamline some of the processes. This helps address some of the organizational issues. The first thing is really work with your business partner to make sure that you can define the business problems clearly and define success metric. Workflows need to prioritize, and the key thing is to really write down anything that seems ambiguous. Again, with machine learning projects, a lot of them can be really complex and hard to interpret, especially for a business client. So it's mission critical to make sure that everything is written in paper and in very clear language so that both parties know what they're getting into. And it's possible that once that process is finished, the business owner might be saying, oh, this is actually not what we're looking for. And that's almost a good thing because you don't want to start a project that almost guarantees no success. The second part is to really use simple models. Again, if you have team members that don't really have the right skill sets, and if that's the majority of your team members, then it's probably better to just start with some simpler models and just build it up with your team members and kind of educate them to make sure that they can start implementing more complex models. The worst thing you can do if you have a lot of junior members on a team is start implementing something that's very complex, because it's going to be really hard for people to follow. And a lot of times people are too scared to admit that they don't know something. So you're going to create this environment where there are going to be a lot of issues and bugs, but nobody really knows how to fix it. And people don't really know where they're coming from because they're not familiar with the models that got built because they were too complex. One thing that's also really helpful is really peer programming. So if you have somebody on your team that's more senior and somebody that's more junior, people can learn a lot from just doing peer programming. So having the junior person work with the senior person, and in that manner can really help speed up the process. And the last one is just really using an agile approach instead of a waterfall approach when delivering some of these projects. And the last point is just purely reducing some of the compute time that we would need. So as I mentioned before, some of the issues that we run into is really it takes a long time to develop a model, or it takes a long time to really implement some of the features. So to reduce that, there are many technical ways. One of them is really to scale out the infrastructure and compute resource. So if you're using a smaller sized machine, if you can scale that up to a bigger size with more parallelization, that could potentially speed up your training time. Again, this is where if you have access to cloud resource, then they could be helpful because you can easily spin up and down a bigger resource that suits your needs better. again, knowing that cost is also one of the things to consider. Another thing is, train on a smaller sample size. If you can identify ways to use a smaller sample size that's still very representative of your whole data, then that's also a way to reduce your training data size, which then reduces the time that you train model. And this is also very useful when you're writing unit tests, because then you can just use a small data size when you run integration or when you run CI/CD. The third one is really just parallelization. So that means when you're doing feature engineering processing, if you notice that there are certain things or there are a bunch of tasks that could actually run in parallel, then it's worth it to take the time and make sure that you parallelize those processes so that you can take advantage of the compute resource of your machine. And the last one is really to just simplify your models. So if you have an ensemble of models, which means if you have 10 models, it's worth the time, depending on the cost, to really investigate and see if it's required to use all 10 models, and if it's possible to just use one instead of ensemble. And for some of the deep learning models, you can convert the model to high precision. And then for traditional models, there are also a lot of hardware acceleration packages that can help reduce some of the compute times. So this is basically just the summary slides of some of the issues that I typically see that hinders different teams to push and iterate their models with speed and into production. So as I mentioned before, data changed or result change. You have some sort of skill set mismatch or organization challenges. And the third one is really just sometimes it just takes long to train, deploy models. And some of the solutions I mentioned, identify the right metrics, implement CI/CD pipeline, make sure that you have clear alignment objectives, write things down, and then also just looking into some of the infrastructure and whether it's to try a smaller data size or use similar models. Again, this is sort of very high level, and I can dive a lot more in depth in each of them, but this is really just to give you guys a sense of what I've observed in the industry, some of the issues and some of the solutions and the tools that sort of support that. But yeah, that's the end of my presentation. Let me know if you guys have any questions, and I also have my contact info there if you guys have questions or if there's something that you guys want to dive a little more in detail.
Yeah, thank you so much. That was a really good overview, and I think it's nice how you provided that slide that sort of encapsulates all the different areas. It would be really great to get into all these in detail. Unfortunately, we don't have time, but maybe this is something we could do for a further session. I have a couple questions, and let's give it some time if anybody there has any questions that they'd like to throw out. Betty, you've worked for startups, you've worked for larger companies, and now for Amazon.
Mm-hmm.
I'm sure you also have a lot of conversations on the side with people that are working in some capacity with machine learning, trying to put models into production, or maybe even thinking about it. You mentioned so many things. Is there anything that really stands out that if you kind of wished companies would address, or maybe be able to understand more clearly, you'd be happier because you wouldn't have to sort of observe this as a roadblock so often? Does anything stand out in particular?
I think the biggest thing to me that really stands out is really, I would say probably communication. So what I mean by that is a lot of time you do have a mismatch between skills of what people know and what people don't know. And oftentimes people are too scared to ask questions or too scared to admit that they don't know certain code. And what happens is that, for engineers especially, they kind of just roll with it and they end up coming up with some sort of processes or results that are either over complex or too simplified because they don't know. So I would say the biggest thing is really to foster an environment where people are comfortable asking questions if it's something that they don't know, or on a company level is to really make people feel comfortable that they can have that discussions. Because, as I mentioned before, machine learning projects are very complex and they're not that easy to implement most of the time. And you have to be very careful each step along the way so you can figure out what went wrong.
Absolutely. And just to build off that, I mean, this is so new and the conditions are so ripe for change, whether it be business problems changing, the data changing, the team size, everything, right? So it's really ripe for just like a bit of disruption within the working team environments. Also, I think that, it's so new and it's competitive on one hand. I mean, so many companies are looking for machine learning engineers as an example. Um, but then also once you're in with the company, everybody's sort of looking to advance their skills or put themselves in a good position, meet the job requirements. Sometimes the job requirements aren't that realistic because companies don't really understand what they're asking for. Like we've all seen those funny posts where they're asking for all these things and you're like, the amount of time that this has existed is not congruent with what you're asking. So it's not really realistic. So I think everybody's kind of stretching themselves thin to fit into these positions. Yeah. And what comes with that is a lot of imposter syndrome. I haven't spoke with many people that haven't felt imposter syndrome at some point in some capacity. So you're right. I think all of those things really contribute to an environment where sometimes you have to sit there and think, do I really want to ask these questions? Do I really want to be vulnerable and like expose myself, quote unquote?
Yeah.
In the environments that have worked for you, that you felt comfortable doing that, what was the key ingredient for that? Is it just like explicitly saying like this is a welcome environment where you can voice yourself if you're not sure? Or what does that recipe look like?
Yeah, I think that's a good point. A part of it, it's a company openly saying that, hey, like these are things that I'm not sure about. What really helps sometimes is that a lot of leaders lead by example. So they sometimes will ask silly questions. I mean, they're not silly, but they will ask questions that people want to ask but are too scared to ask, even though themselves they might know the answer, but they do it to sort of promote that kind of environment, right? So they might ask something that's very, very small or very granular, like, hey, how did this feature, why do we need this feature? Or like, what does this feature do? Or how does this pipeline work? Then I think that case it encourages employees to also ask those questions, given that you have your leaders kind of asking those questions and saying that, oh, like, this might be a dumb question. I don't know this, but I'm just here to get educated. So those things also really help.
I spoke with somebody recently that while in the interview, she mentioned that she'll also ask a question back to the person that's interviewing her that she probably has a better idea of the answer for, but she just throws that out there to see how they respond. So if they respond with this sort of disgust and like, we're insulted that you'd ask that, or it's a good read on what the experience will be like working for that person. So I think that was an interesting approach that they had. I really thought that was so unique. I've never heard of that before, and a lot of people wouldn't have the confidence in themselves to do that. But at the same time, if you're really invested on your quality of work and just the interaction and communication you have with your team, something like that can be a big tell. It's very interesting. I also wanted to ask, you mentioned something that I thought was very interesting and very tricky as well, which is identifying the business problem very clearly in clear language and making sure it's not opaque, it's not vague. You also mentioned one of the big problems specifically when you're working in an agile, like sort of startup environment where the models take 6 to 12 months to put into production environments, but also the business challenges or the business problems you're solving might change every quarter or every other month.
Yeah.
For a company that builds themselves up or maybe promotes themselves, or maybe they're hiring for and building their team, specifically around machine learning and AI, what is this just a standstill process if they don't have a clear definition, or is there anything that they could do in the interim period so that they are still somewhat positioning themselves to be successful, even if they don't necessarily have one specific business problem that they've honed in on?
I think that goes back to really using agile, and it's a very much an iteration process. A lot of the machine learning models can be a proxy using analytics, right? So what could work is that you have a process where business people might have some big ideas or some vague ideas as in what they want to explore. Some people can quickly put together an analytics solution for those problems and present that to the business team to get a sense if that's actually what they're looking for, right? So once it's clear that, okay, they're looking for a churn problem or they're looking for XYZ, then the team can go back and actually build a machine learning model that's better than the analytics solution, for example. And that way and then if you are able to do that machine learning fast, you're able to kind of get that fast iteration feedback with your business team to constantly letting them know, this is what we have, is this what you're looking for? And as you have that iteration process over and over again, it's going to become clear to the business team whether that is something they need or that is something that they don't need. And it's good to get that feedback, because you're not really, even if it's something that they don't need, you're not really wasting time, because you know what that relationship looks like now, and you know what that cycle looks like now.
It's a really good point. And it speaks to the maturity of how long it's come. If a company can do that successfully, it speaks to the maturity with regards to understanding the processes involved and so on and so forth. I remember years ago, coming across a lot of just informal conversations, speaking with business leaders and folks that would either invest in teams or looking to explore where models of production might fit their problems, their solutions, or the things that they're looking to address. And it was very striking how little understanding they had with regards to the process of what's involved. And we could talk about team size, team construction, amount of investment, amount of time it takes, to the extent that a lot of people, I think, early on weren't really on the technical side. They weren't being set up for success. A lot of demands were made for them, a lot of expectations, and there wasn't much clarity into that process. I'm just curious for you, Betty, when you speak with people, even anecdotally, getting a gauge or a pulse on the state of the industry, what's your gauge? Is it still kind of like that, where it's the Wild West and people either do they get it a little bit more now? Are they starting to understand this process, or is it still, do you find when you speak with people this big gap between like, here's where the possibilities are and here's where your expectation, and there's just this huge gap in between?
I think the industry is maturing a little bit, so we do start to get into the process of a lot of people starting to understand machine learning problems a little bit better and how to address them. But with that being said, there's definitely still a lot of companies out there that don't really understand, what it takes to build a machine learning model. And for those companies, the gap is almost even bigger, because there's been so much advancement on the actual technical side, right? So in their mind, they're thinking they could do so many things because they hear so much things in the news. But when it comes to it, it really comes down to the data that a particular company have, their business objective, and how they want to come and solve that problem, right?
That's a great point. I guess last question for you, Eddie, and this is more of a personal one for you. Do you have any advice for those that are looking to advance themselves in their career, or take a similar trajectory as you, perhaps? Like, what has allowed you to constantly improve on your skills and grow and be able to hold down these positions in the industry? Do you have anything to offer, or any suggestions or advice?
I think the biggest thing is just be curious, be genuinely interested in what you're looking to do, and sort of letting yourself go very deep in that curiosity. So whether that's from reading different books, or actually make sure that you're delivering the highest quality of code that you can, or just always try to strive for some sort of excellence, given that you have that curiosity driving behind you, I would say.
That's great, and I think that's a good way to wrap this up. Betty, thank you so much. It's been great. I hope we have you back soon, and you have a lot to offer. So I really appreciate you sharing this with the community, and hope to see you again.
Thank you. Thank you for the opportunity as well. Really appreciate it.
Yeah, and thanks everybody for joining. I think this is the last one here for us tonight, so we'll be wrapping up and sending the videos off. We hope to see you again for our next event. Thanks, everyone.
Thank you.